All right, let's just jump right in. We are about to tackle one of the biggest, most mind-bending questions anyone has ever asked. Seriously, this is a mystery that's 4 billion years old, a cold case of cosmic proportions. We're going to play detective and investigate the origin of life itself. And that brings us right to the heart of it, the one question that frames this entire story. How do you go from just rock, water, and gas to a planet teeming with life? How does a sterile ball of rock spinning in space suddenly wake up? Think of this as a detective story. You and me, we're going to follow the clues together. So, every good mystery needs a setting, right? A scene of the crime. And for this story, our crime scene is early Earth. And let me tell you, it was a rough neighborhood. A brutal, chaotic, and you'd think, totally impossible place for anything to get started. Now, what's just staggering to think about is the amount of time we're dealing with. After our planet formed, it just sat here for almost a billion years. Can you imagine that? A whole world with oceans, but completely silent. No life swimming, no life crawling, just a long, long, quiet wait for the story to finally begin. So what was it actually like back then? Well, it was a nightmare. I mean, an atmosphere with zero breathable oxygen, volcanoes erupting all the time, meteorites constantly slamming into the surface, and our young sun just blasting the planet with unfiltered UV radiation. But here's the crazy part. This violent chaos was also the perfect storm, because it provided the two things life absolutely has to have: raw materials and a ton of energy. Okay, so we've got our crime scene. Time for Act 2. Like any good detective, we need to figure out the how. In our case, that means understanding the fundamental recipe for life. What ingredients did you need to cook up biology from just simple chemistry? There's a scientific term for this, and it's called abiogenesis. Yeah, it's a fancy word, I know, but the idea is actually pretty simple. Life from non-life. That's it. This is the absolute core of our mystery. How you get from a bunch of boring, non-living chemicals to something that can grow, react, and, this is the big one, reproduce. And here's the kicker. Our chaotic early Earth had all three of these key ingredients, and lots of them. You had massive energy sources, right? Lightning, volcanoes, that intense UV radiation. Check. You had organic molecules, the building blocks of life, either forming right here or maybe getting dropped off by meteorites. Check. And you had liquid water, the ultimate solvent where all these goodies could mix and mingle. Check. So we've got the scene and we've got the ingredients. But, a pile of flour, sugar, and eggs on your counter isn't a cake. You need a kitchen. You need a specific place where the chemistry can get organized and something truly magical can happen. So let's head into Act 3 and look for that primordial spark. This brings us to the two leading theories for where this kitchen might have been. So was it in a warm little pond on the surface, just like Charles Darwin once imagined? A shallow pool where chemicals could get concentrated and then zapped by lightning? Or was it deep under the ocean at these crazy places called hydrothermal vents? These are basically underwater volcanoes, pumping out superheated, mineral-rich water that could have powered the first life. Both are really compelling crime scenes. But look, just mixing a bunch of chemicals together isn't enough. The real breakthrough, the moment chemistry flips the switch and becomes biology, is when a molecule learns a new trick: how to make a copy of itself. This is everything. Replication is the secret sauce. It's the foundation for heredity, for evolution, for all of life as we know it. And that idea leads us to this really cool theory called the RNA world hypothesis. The thinking is, before DNA came along, RNA ran the whole show. And why RNA? Because it's a brilliant multitasker. It can store genetic info like DNA, sure, but it can also act like a little machine to speed up chemical reactions, including making copies of itself. So once you have self-copying RNA, you've just kicked on the engine of evolution. Imperfect copies mean you get variation, and the most stable, fastest replicators start to win out. We are so close now. We've got these self-replicating molecules, the engine of life itself, just churning away in some primordial kitchen. But there's one final clue we need to find: the masterstroke that's going to solve this entire 4 billion-year-old mystery. The protocell. This is the absolute game changer. So what is it exactly? Well, think of it as the very first house. You see, simple fatty molecules, lipids, they naturally form little bubbles in water.
And if some of that self-copying RNA happened to get trapped inside one of these bubbles, bam, it suddenly has a safe house, a stable, protected little environment totally separate from all the chaos outside. This bubble, this protocell, is the ancestor of the modern cell. It's the birth of the individual.
And here's the part that should just give you chills. Every single living thing on this planet, every plant, every animal, every fungus, every tiny bacterium, we all share the same basic biochemistry, the same genetic code. And what that tells us is that this incredible process probably didn't happen millions of times. It likely happened successfully just once. We are all descendants of a single ancient population of cells we call the last universal common ancestor, or LUCA. From that one tiny successful protocell, the entire magnificent tree of life grew.
So we've done it. We've traced the clues from a barren rock all the way to the ancestor of you and me. But solving one mystery just opens up another, even bigger one. If the ingredients for life, energy, organic molecules, and water are actually pretty common out there in the universe, and the laws of chemistry are the same everywhere, then if it happened here, on our little world, has it happened elsewhere? Now that's something to think about.